All right, so we are on chapter 6, section 2, and we're going to talk about those functional groups, and we're going to focus on monosaccharides right now. We'll talk about larger molecules later. So you are going to be so proud of yourself and so happy that you memorized those functional groups, because they're going to come in handy so much in this section and in future sections. So if you haven't memorized them, please, please, please go and memorize them. All right, so ethanol is one of our simplest members of the family of organic compounds that we know as an alcohol. And an alcohol is sometimes also called a hydroxyl group. So what makes something an alcohol is this OH right here. So an OH together. So we know that we can produce ethanol from the fermentation of simple sugars. So here's an example of a simple sugar that we could ferment and we could produce ethanol. And so that ethanol that we produce, typically we put that inside of liquor, beer, wine, those kind of things. But we also use it as an additive in alternative fuel blends. So you know how the gas stations here, you don't want to run an ethanol inside of your boat engine, right? And so gas stations will say ethanol free. And that's because ethanol can be inside of your fuel. Okay, so alcohols are classified depending on how many groups are attached to the carbon atom. And so we say alkyl groups, right? Because what's an alkyl group? It's something with a carbon in it, right? All right, so a primary alcohol has one alkyl group attached to the carbon. So here's our center carbon, right? And so we're going to look all around our center carbon. This center carbon has a hydrogen, a hydroxyl or an alcohol group, another hydrogen. Oh, now we got something with a carbon, right? So here we have one carbon attachment that makes it a primary alcohol. So it's always talking about the number of carbon groups that are attached to it. A secondary alcohol is going to have, guess what? 1, 2 carbon groups attached to it. So 1, 2, that's where the number is coming from. Primary, secondary, and tertiary, you guessed it, is 3. 1, 2, 3. Okay, so monosaccharides most of the time contain primary and secondary alcohols. You're not going to see so many tertiary, but you still do need to know how to classify them. All right, so let's try to classify these alcohols as primary, secondary, or tertiary. So when you're looking at this, what you want to do is to find your alcohol. So here's our alcohol, and then I want to see where's my carbon that's attached to that alcohol. It's right here. Now I need to look at this carbon and I need to see what different groups are attached to that carbon. Well, I have a carbon, and then it doesn't show it, right? But I need 4 bonds, so I really do have a hydrogen attached to it. But I'm not really worried about the hydrogens, I'm really worried about the carbons. And this is really a CH3, and this is really a CH3, right? And so if I look at the carbon that's attached to my alcohol, how many groups do I have attached? 1, 2, that makes it a secondary alcohol, okay? Here's another example, right? We find our alcohol, we look at the carbon attached to it, and we see how many other things are attached to it. So that's a carbon. You know that it's got 2 hydrogens as well, but we're not so worried about the hydrogens. What we're really worried about are those alkyl groups. So here we have 1 carbon attached to it. So this is a primary alcohol, okay? All right, so there can be other functional groups inside of our monosaccharides. The aldehyde family is one that you're going to see in monosaccharides. So remember your aldehyde, that you have a carbonyl group. And what's a carbonyl group? That's an oxygen double bond to a carbon. That's your carbonyl group, right? That's the blue part right there. Then it has a hydrogen atom bonded to one side of the carbonyl, and then an alkyl or an aromatic group bonded to the other. So we're just going to label that as R. And so this is exactly what was in the previous section. So when you look at this, a lot of times these members of this family are very, very odorous, right? In a good way or a bad way, but you can smell them really well. So benzaldehyde is one that has an aldehyde functional group. So here's your aldehyde functional group, and it's attached to an aromatic ring, right? So a benzene ring. And so this makes it smell. So this is basically the artificial flavoring of cherry. It's not real cherry flavoring, but it's artificial. The other one that's very, very simple, right? Here's our aldehyde group. And in this case, instead of having an alkyl group, right? This one actually is the simplest, and it has a hydrogen, and this is formaldehyde. And if you've ever, well, so they don't use formaldehyde anymore because formaldehyde can actually cause cancer and things like that. So we don't really use formaldehyde anymore. But if you were ever in a dissection, right, and you can smell that smell, it comes from a similar compound that does have an aldehyde group on it. So you can really smell it. All right, the other functional group is our ketone. Now our ketone is super similar to our aldehyde, so you have to be very, very careful. Ketones have an alkyl group or an aromatic group on both sides of the carbonyl. So I'm going to give you a little thing to remember this, right? Here's our ketone. Our ketone has our carbonyl, right? So this is our carbonyl. We have an oxygen double bonded to a carbon. That's our carbonyl group. And then it has two things on the side of it. And I'm not talking about hydrogen. I'm talking about something with carbon inside of them. So that's our alkyl groups. So remember, a ketone, if you have a key, you need a lock. So you need two things. You need the key and the lock. So if you have a ketone, you're looking for two things. Aldehyde, right? Aldehyde alone, it's only one thing. So here I have one R group, that's an aldehyde. Ketone, I need a lock and a key, I have two. Okay, so make sure you keep that ketone and aldehyde separate in your minds. And so we see ketones in all kinds of different substances that we interact with on a regular basis. But we're gonna do some looking at that now. When we classify these functional groups, right, we're going to have to use a name to say, okay, these monosaccharides have an aldehyde in them. These monosaccharides have a ketone in them. And so when they have an aldehyde, we call it an aldose. So ald is the part that says aldehyde, and then ose tells us it's a monosaccharide, tells us it's a sugar, right? Like glucose, right? Fructose. That's all of that is telling us that we have a sugar. So we're being told the functional group and we're being told the sugar, right? Now, a lot of times it's really, really important to tell how many carbons are inside of that sugar, right? That's what we just talked about in the last section, that we need to know how many carbons are in there. So if we look at a monosaccharide that has, let's say, 3 carbons, that is going to be a triose. And then you're going to combine the two, and you're going to combine knowing what the functional group is, knowing how many carbons it is, and then putting the ose on the end. So we're going to practice naming some of these. And so when you're trying to look at how many carbons there are, remember this is very, very similar to writing the prefixes for our covalent compounds, right? Tri meaning 3, tetra meaning 4, pent meaning 5, and hex meaning 6. So there's another way to draw carbohydrates instead of in that ring structure. And so the way that we draw a lot of times carbohydrates is using what is called a Fisher projection. And so it's very similar to a skeletal structure. And I'm going to explain in detail how we come up with these Fisher projections in the next section. But for right now, you just need to be able to look for it and be able to count the carbons and find the functional groups. That's all you have to do is analyze it. I'll teach you how we get these Fisher projections in the next section. Okay, so if you look at our first molecule here, right, what we have is a carbon here. And that carbon is attached to only one other alkyl group. So if it's only one other alkyl group, right, that's an aldehyde. If it's an aldehyde, we call it an aldo. And then I also need to know how many carbons. So I'm going to count my carbons. I'm going to go 1, 2, 3, 4, 5, 6 carbons. So 6 carbons is hex, right? So aldo hex, and it's a carbohydrate. So we say ose, aldo hexose. Okay, so let's try another one. Another one, here's my functional group. So you're always going to look for your carbonyl group, right? Okay, there's my carbonyl group. And so what I'm looking for here is the carbon that's part of my carbonyl group. Sorry, y'all. My carbonyl group. I want to see what's attached to it. There's 1, 2. So remember, if there's 2, it's like a lock and a key. So you need this is a ketone. Okay, that's a ketone. So if I have a ketone, I'm going to start with keto, and then I'm going to say how many carbons. I have 1, 2, 3, 4, 5 carbons. So that's pent. And then we're going to say it's a carb. So that's pentose. So keto, pentose. So these are general classifications for these monosaccharides. So let's try some new ones. And I kind of put on here, this is my suggestion to you, is to also kind of maybe practice drawing these aldehyde and ketone groups so you know what you're looking for. So remember, you're always looking for your, let me change my color. You're always looking for your carbonyl group. So I have my oxygen double bound to a carbon. So that's my carbonyl group. So I'm going to kind of erase that just so I can see. Now I need to see what's attached to that carbon. I don't know why they did this. I really don't like that they did this, but they're showing a bond to hydrogen. And we all know that in our skeletal structures, we don't show bonds to hydrogen. So just kind of be aware of that. Sometimes your book does that. I don't like it, but it does that. So how many different carbons, carbonyl groups, not carbonyl groups, how many carbons or alkyl groups are attached to our carbon that's attached to the oxygen? Well, only one. One is an aldehyde. An aldehyde, okay? So let's see what it say. Circle and label the ketone functional, the aldehyde or ketone. So we need to circle it. So we're gonna circle, this is our aldehyde, okay? All right, let's try another one. Raspberry ketone. Well, ooh, they kind of gave you away on that one, right? They said it was a ketone. Okay, but here's our carbon, part of the carbonyl group. What's attached to it? So I have a carbon here and I have a carbon here. So if I have 1, 2 things attached to my carbonyl, that must be a ketone. And I'm going to circle it. I need to include my carbons that are attached, and there's my ketone. All right, one more. One more. So we're looking for a double bond oxygen. You have 2 oxygens. But which one is the one that we're focused on today for our ketone and our aldehyde? It is this one right here. All right, so find your carbonyl carbon and look at what's attached to it. I have a hydrogen, but that's not going to help me. Now there's my carbon. So the only other thing attached to it is I have 1 carbon. If that is 1 carbon, that is going to be an aldehyde. And I started writing ketone, aldehyde. Right? And so now we need to circle our aldehyde. So here's our aldehyde, okay? And that's it. We're gonna go do a few more practice problems. All right, here we go. So section 6.2, we're talking about our functional groups. So the first one we're gonna talk about is alcohols, right? So if we're gonna characterize these alcohols as primary, secondary, or tertiary, what we need to do is find our alcohol. Here's our alcohol. Find the carbon that's attached to the alcohol. Now, this is where I'm going to get my information. How many different carbonyl groups, alkyl groups, why do I say that? Alkyl groups are attached to that carbon. So 1, 2. I have 2 attached. So because there's 1, 2, I'm going to call this a secondary alcohol. All right, the next one, B. I know it's kind of weird over here, but so what I want to do here is I want to look at my alcohol and look at my carbon that's attached to the alcohol. And then I'm going to see how many carbons are attached to that. So there's only 1 carbon that's attached to that. If you wanted to draw this out, you absolutely can. You know your alcohol is attached to your carbon, right? And now here's the rest of the molecule. So you have a carbon, there's your hydrogen, and then another carbon, and then another carbon. And this one needs 3, and I'm running out of room. Right, okay. So there, what you can see is that there is only 1 alkyl group attached to my carbon that's attached to my alcohol. So that is a primary alcohol, that's B. All right, C, if I look for my alcohol, here's my carbon that's attached to my alcohol. And now I want to see what's attached to that carbon. Well, I have 1, 2, 3 groups attached to that. So this must make it a tertiary alcohol. All right, now here's our alcohol. Here's the carbon that's attached to that alcohol. And then I want to see what's attached to that carbon. So I have 1, 2 groups attached to it. So this is a secondary alcohol. Okay, so just make sure you're looking at the right carbon. I think that's where most people kind of get tripped up. So let's go talk about our other functional groups, right? Our 2 other functional groups. Identify each of the following compounds as containing an aldehyde or a ketone. It never hurts to draw these different groups, right? My screen had a big lag on there. Sorry about that. All right, so it never hurts to draw these 2 groups, but remember our kind of trick, aldehyde is alone. It only has 1 R group. And then ketone, you need 2 for a lock and a key. So that's 1, 2 groups, okay? So that's your nice little reminder. So we're trying to identify our ketone. What we are looking for is our carbonyl carbon. So this is a carbonyl, right? We have a carbon double bonded to an oxygen. So now I'm going to see what I have attached to that. Do I have 1 group or 2? Well, here's another carbon and here's another carbon. So that's 1, 2. So this must be a ketone. Must be a ketone. All right. So now if we look at our next one, this is our carbonyl carbon right there. And now we want to see what's attached to it. Here's a carbon, here's a carbon. So we have 2 things attached. That is a ketone. Here's our carbonyl carbon. Right, now be careful because they're showing you that hydrogen bond, but we don't worry about that. We're just looking at what's attached to this carbon. There's only 1 other carbon containing group attached to it. So that must be an aldehyde, right? Alone, 1 alone. Here's my 1 alone, and it is an aldehyde. All right, now we're looking at these different structures of our Fisher structures. And so for this one, what we want to do is classify by type of carbonyl group, number of carbons, and then we need to say that it's a carbohydrate. So when you do this, I want you to kind of keep in mind that you need 3 parts, right? You need a functional, excuse me, a functional group. This is going to be a part of the name. So a functional group. You need to list the number of carbons, and then you need to end it in OSE. So that's our end. So those functional groups are going to be one of 2 things. Either it is going to be an aldehyde, and we'll say aldo, or it'll be a ketone, and we're going to say keto. Okay, and then just kind of remember your difference between an aldehyde and a ketone. So keep that in mind. All right, so the first thing I want to look at here is functional group. So if I'm looking for a functional group, I see an oxygen double bond to a carbon, so that's my carbonyl. And now I want to see what's attached to that. Well, what these stick figures mean are anywhere where you have a meeting of the two lines, a vertical line and a horizontal line, that's telling me that there's a carbon right there. So I know I have carbons here, and we'll learn in the next section why that is. I don't particularly like the order of this, but it's okay. All right, so how many different things do we have attached to this carbonyl carbon? We only have one, so that's an aldehyde. I'm trying to spell right, aldehyde. All right, now, so when I write my name, I need my three parts. I'm going to start with my functional group, so that's aldo. Now I need to know how many carbons. Well, let me count my carbons. 1, 2, 3, 4, 5. Be careful, 6, right? Because here's another carbon right there. Okay, so if I have 6 carbons, that's going to be hex. And then I want to say that it's a carb, so hexose. So aldohexose. All right, let's look at our next one. I find my carbonyl. Here's my carbonyl. Now, how many different things do I have attached to that? I have 1, and then there's another carbon right there. So if I have 2 things, lock and a key, that's ketone. Okay. So now I need to start my name. I'm going to say keto, and then I need to count my carbons. So I kind of like to write in my carbons to make sure I know how many there are. And I'm going to go 1, 2, 3, 4, 5. So 5 is pent. So keto, pent, and then I want to end it in ose. Okay. Last one. We're going to see our carbon here. This is part of our carbonyl group. And so we want to see what's attached to that. Well, I have a carbon right here. So that is 1 attachment. So 1 alone is aldehyde. So I'm going to write in my other carbons just so I can kind of keep track of them. And I'm going to count them. 1, 2, 3, 4. So when I go and write my name is going to be aldo. And then I have 4. So that's tet or tetra, but we don't put the A because it's 2 vowels, OSE and A. So be careful of that when you type it in on the homework. But on the exam, it'll be multiple choice. So I would not take off on spelling anyway. So tetrose, okay? And I think that is it. Yes, that is it. Yay, have a great day.